you share the link the other
First
time?
time.
Will I share it? So, settle down. Wúrà ò ní bí ní nǹkan tí ṣe wá sọ. When you were not around, wọ́n ní where is Wúrà? Ṣé wàá ní pé àtúndà náà máa lò wó lé ìmọ̀ ọ́n náà máa lọ fún pé. Ó ní òmò pé kò ní bẹ́ẹ̀ la máa ti Wúrà. Ó lò máa fojú di wọ́n tẹ́lẹ̀. Ó ní wọ́n náà lọ fún pé ṣe wà áhà. Wọ́n ní kí n má sọ ọ̀mọ lébè òkú pààrọ̀. Oya jẹ́wọ́ ṣé wọ́n lò ra bisikíìtì tó jẹ? Jẹ́wọ́ amọ̀ra wa. So that's my number, popularly known as Dr. Sodium. You that you're interested, then you are told now. You don't have to say anything. Just get used to your book. Get used to your book. So, we already defined the first part, the second part. So I told you that if you have a compound like this, and you form a product like this, I said, do not pick your answer from the right hand side. Your answer is always on the left hand side. And if they say that which one has undergone oxidation here, it has undergone oxidation, copper has undergone reduction. Is that taken? Yes. So your answer is reduction. Then you can also say that removal of highly electropositive elements. All these ones are just identify which one is undergoing oxidation and which one is undergoing reduction. The most important part is what we want to talk about now. And even if you did not get all the things you have been saying since morning, try your best to understand what I'm about to say next. Look at this. If you look at this reaction, what am I trying to show here? Sodium went from sodium atom to sodium ion. And before it could form an ion, an electron was removed. Abi? Now, if you look at the configuration of sodium here, it's going to be 281, right? But here it's going to be 28. Now, look at the one that is 281. It does not have a charge. The one that is 28 is that it has a charge of +1. Look at this. Al 2,8,3 will give me Al 3 plus then 2,8 plus 3 electrons. Note something. What this guy carries, we call it oxidation number. Abi? This +3 and this plus, we call it oxidation number. But if you notice something, one electron was lost here, this one was +1. Abi? 3 electrons were lost here, and this one became +3. That means one thing: the more you lose electron, the more your oxidation number. Do you agree to that now? If you look at what we have here, this one lost just 1 electron, it has +1. This one lost 3 electrons, it has +3. So the one losing electron, this electron loss here compared to this one lost more electron and the oxidation state is higher. This one lost 3 and it became +3. This one lost 1 and it became +1. So the more you lose electron, the more your oxidation number. So let's now come back. Oxidation is now defined as loss of electron. Oxidation is loss of electron. Reduction is gain of electron. All you just need to remember here is oil rig. Oil rig. Oxidation is loss of electron. Reduction is gain of electron. Oil rig. But I want you to notice something. That's why I first said that part. Now, between oxidation and reduction, if you listen to what I've said here, which one do you think will lead to increasing oxidation states? Is it oxidation or reduction? Oxidation. Oxidation. Are you sure? You know, oxidation is loss of electron, and if an element loses electron, there will be an increase in oxidation states. The more the electron loss, the more the oxidation states. I hope you get that, because it's a common mistake at times. So this one is going to be having an increase in oxidation states. Is that taken? Why this will be what? Decrease in oxidation states. Let me show you what this one is talking about. If I have Al3 plus and this guy gains 1 electron, it will become Al2 plus. This is 2,8. This is going to be 2,8,1. Abi? Because plus 2 shows that it has only lost 2. You should know this. You have been doing ordinary atomic structure since. And this is 2,8, meaning it has lost 3. Abi? You know what I'm saying. So what happened here? This one gained electron. This process now, they ask you that what process is this? It is reduction. Because this guy is gaining electron, Abi, and is reducing oxidation states. This guy is losing electron. You can see the way it's written. Most times when electron is gained, it is written on the right side, on the left side. When electron is lost, it is usually written on the right side. Look at this equation and look at this equation. This one says that this guy is gaining electron. This one says that this guy is losing electron. Do you get that? You know, you lose something that is on the product side. On the reactant side, that is what is involved. So now, there is a decrease in oxidation number for this reduction process, but there is an increase in oxidation number for here. So, the moment you understand these two statements, you never have any problem again. On this topic, the moment you understand these two processes, then your problem is almost solved. So, all the stories we have now been saying since morning, oh, which one is undergoing oxidation, which one is undergoing reduction, then these statements can help us to deal with it. Let's look at this guy again. There are some reactions that don't involve oxygen. For example now, look at this reaction. Sodium plus chlorine to give sodium chloride. I now ask you, which one is undergoing oxidation? The first statement, we said this is an oxidation reduction process. So I'm now asking that which one is undergoing oxidation here? How did you know it's sodium? Because of the oxidation state. Here it is 0. Here it is plus 1. It is plus 1. So it went from 0 to plus 1. Here it is 0. But 0 went from 0 to minus 1. And 0 to minus 1 means decrease. Abi? 0 to plus 1 means what? Increase. So, even if there is no oxygen, there is no hydrogen, you can still tell which one is undergoing oxidation, which one is undergoing reduction. What you just need to know is these two statements. So, yeah, let's go to this now. Look at what you have here. I want to ask all of you, I'm going to give you the rules to identify it, then we'll come back again. For this zinc now, what is the oxidation state? It's carrying nothing, Abi, so it's 0. For this copper, what is the oxidation state? So those of you that might not know, this is Cu2 plus O2 minus, abi? So 2 and 2 they exchange, that's why it became Cu2O2. Then for simplified form, that's CuO, abi? So this compound, copper is +2, oxygen is -2. Do you agree? If you come to this side, what is this zinc carry? Zinc is also +2, abi? Oxygen is what? -2. This copper is what? They now ask you that which one is undergoing oxidation. So you look at it. Zinc went from where? 0 to +2. So zinc is the one undergoing oxidation. So you don't need all those hydrogen, oxygen. This is what we need, these two statements. But you just need to know this. They can theoretically ask you. Now, if you look at here, copper is going from where? +2 to 0. That's what? Reduction or reducing. But think about it. Before you go from +2 to 0, are you gaining electron or losing electron? So look at it carefully. You are gaining. This one is going from where? 0 to +2. That means I can write it as Zn to give Zn2 plus 2 electrons. So it's losing. But for this now, this one is going from +2 to 0. So meaning that it can be Cu2 plus 2 electron to Cu. So this one went from Zn to Zn2 plus, Zn to Zn2 plus. This one went from Cu to Cu2 to Cu0, from Cu2 plus. From Cu2 plus to Cu. So this one is undergoing oxidation because there is an increase in oxidation number. This one is undergoing reduction because there is a decrease in oxidation number. And that's why we taught you some topics before. We taught you atomic structure. We taught you periodicity. We taught you chemical bond. If you understand these three topics very well, what I'm saying will make sense to you. So these are the basics. So to some extent, let's now look at what oxidation number is. Then I'll come back to this again. Then all of you will now come and tell me what your answers are. For now, I still believe there is not everybody that understood what we have done here. But let's look at what oxidation number is, in case you don't know how I put all of these things. So oxidation number is defined as an indication. Oxidation number is defined as an indication of the number of electron loss or gain Can we say sodium undergoes oxidation because the more electronegative element is added to oxidation? Yes, it applies. If that's the question. Chlorine is more electronegative, and you added more electronegative to this guy. Sodium is electropositive. Is that it? So it still applies. But here you can see that sodium here is 0, chlorine here is 0, and sodium here is what? +1. Chlorine here is -1. So going from 0 to +1, that's an increase. 0, +1, +2, that's an increase, Abi. But going from 0 to -1, that's a decrease. It's better you don't have anything than go to get this year your home. So that's a decrease. So this one is undergoing reduction, this one is undergoing oxidation. But when you listen to what I'm about to teach now, you'll be able to determine in total. So oxidation number is defined as an indication of the number of electron loss or gained. As the number of electron loss or gained in a chemical reaction. So it's an indication of the number of electron loss or gained in a chemical reaction. Rules to determine oxidation number. Everybody now, if I write this, O2 minus, what does that mean? If I write this, what does this mean? So this has lost 3 electrons, this has gained 2 electrons. So oxidation number is telling us that this has lost 3, this has gained 2. So it's an indication of the number of electron loss or gained during reactions. So what are the rules we use when we're talking about oxidation number? So rule one. We should know some things which we have talked about before when we did chemical bonding. Generally, what's the oxidation number of group 1 element? Plus 1. Abi? Group 2 plus 2. Group 3 plus 3. Group 4 4. Abi? Group 5 plus 5 or minus 3. Abi? We talked about that when we did chemical bonding. But let's assume we don't even know. So let's just note this one. Oxidation states of hydrogen is usually plus 1. So everywhere you see hydrogen, it is always plus 1. So we want to follow rules now. Oxidation state of hydrogen is usually plus 1, except in metallic hydride. Oxidation state of hydrogen is usually plus 1, except in metallic hydride. Are you ready? So, if I say metallic hydride, that means hydrogen is joined to a metal. When hydrogen is joined to a metal, okay, except in metallic hydride, where it is minus 1. Where it is minus 1. So, if I say sodium hydride, this hydrogen is joined to sodium. Sodium is a metal, Abi. So anytime you see hydrogen with a metal, know that the oxidation state of hydrogen is minus 1. That of the metal is going to be plus 1. If I now say H2O, what is the oxidation state of hydrogen here? Plus 1. In every other compound, aside when it is joined to a metal, it is always plus 1. Did you get that? Don't use this number to determine. Some of you, because of this number, you used to say it's plus 2. You would have multiplied the 1. No. This just means that you have it 2 times. You have H plus 2 times. That's what it means. Do you get that? So, if I give you H2SO4, what's the oxidation state of hydrogen here? Plus 1. So which means that everywhere you see hydrogen in a reaction is always plus 1, except when it is joined to what? A metal. Do you get that point? Those are the rules we'll use now. So number 2, oxidation state of oxygen is always minus 2. Oxidation state of oxygen is always minus 2, except in peroxide. Except in peroxide. So in that peroxide, open a bracket and put minus 1. And superoxide, except in peroxide, so you open a bracket, then you put it minus 1, and superoxide, where it is minus 1 over 2. So you open a bracket, minus 1 over 2. So which means that everywhere you see oxygen is always what? Minus 2. So if they ask you that what's the oxidation state of oxygen here? In H2O, it is minus 2. In NaO2 or in Na2O, it is minus 2. These are normal oxides. But if you have H2O2, this is called what? Hydrogen peroxide. Abi. So if they ask you that what's the oxidation state of oxygen here? What's the oxidation state of hydrogen here? +1. So which means if you don't know oxygen, you can calculate it. So you can, we will see how we will calculate it soon. So here now, oxygen will be -1. Anytime it is peroxide, it is -1. Is that taken? And in superoxide, it is usually -2, -1/2. Those are just the exception. So, but in every other compound, it is usually -2. So we'll see in some examples as we move on. Number 3. Fluorine is always -1. Anywhere you see fluorine, it is always -1. Fluorine is always -1. Number 4. So anywhere you see fluorine, just know that fluorine in that compound is always -1. Number 4. Some elements can have different oxidation states in the same compound. Some elements can have different oxidation states. Some elements can have different oxidation states in the same compound. So for this sake now, marvelous. It's maybe you are trying to enter the world with your head. So I said what? So if I have like the question one of you asked when I was teaching the last class, I think Fe3O4. This is a compound, but in this compound, there is one element that has different oxidation states. The compound can be broken down into two, FeO and Fe2O3. In this FeO, the oxidation state of iron is +2, and in Fe2O3, the oxidation state is +3. So in this same compound, iron has both +2 and +3 oxidation states. Just note that, comma. So example, Fe3O4. Another example, ammonium nitrate. Ammonium nitrate. In ammonium nitrates, we have NH4 plus and we have NO3 minus. So they can say what's the oxidation state of nitrogen in these two compounds. How I got it, I'll let you know as we are moving on. So this is going to be -3, and this is going to be +5. So the oxidation state of nitrogen in ammonium ion is -3, while the oxidation state of nitrogen in nitrates is +5. All in ammonium nitrates. Number what now? That's 3 times 2, 6. Yes, now -6. -1 plus 6, that's +5. I'm not doing calculations yet because some of you might not know how I got it. So let's move on. So do you understand this? Number 5. The algebraic sum of all the oxidation states of the individual atoms in a mononeutral compound is equal to 0. The algebraic sum of all the oxidation states, the algebraic sum of all the oxidation states in a neutral compound is equal to 0. 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 E.g. example, KMnO4. It's a molecule, it's a compound without an ion. So this is said to be a neutral compound. Manganese is an element that can have variable oxidation states. It's one of those transition elements. So the rule is now telling us that how can I determine this oxidation number? Then he said that I will sum everything, the summation of all of the oxidation states, the one for potassium, plus the one for manganese, plus the one for oxygen, everything will be equal to 0. That's the rule. So which means that potassium, as we all know, is a group 1 element, Abi, and you should know its oxidation number. The oxidation number is what? +1, because it's a group 1 element, Abi. What's the oxidation number of oxygen here? It is -2. We said, if you go back to the notes, we said anywhere you see oxygen, it is always -2, except in what? Peroxide and superoxide. Do you get that? So now, they now say I should determine that of manganese because it can have different ones. So what is that? So you will now say that, oh, this one is +1. So you say +1, you sum everything together. Plus that of manganese you don't know, you call it X. Plus how many oxygen do you have? 4. Then each oxygen carries what? -2. Then you put -2 in the brackets. Then you equate everything to 0. So the rule is saying that the sum of all of the oxidation states will be equal to 0. Do you get that? So at the end of the day, this will now be 1 plus x minus 8 equals 0. Then x is going to be, when it comes here, it comes to positive, then -1, and that's going to be what? +7. So the oxidation state of manganese here is what? +7. So the name of this compound is, we'll start with the metal, potassium, 4 oxygen here. So that will be tetraoxo manganese 7. So that's the name of the compound, Abi. So V2O5, what is the oxidation state of this guy? Determine that. K2Cr2O7, what's the oxidation state of chromium? Determine that. Fe NH3 4 Cl2 Cl. Determine that of iron here. H2SO4. Determine that of sulfur. We are fast. Tell me your answers when you are true. So move on to the next rule. Are you sure? V2O5, K2Cr2O7, FeNH3Cl2Cl, and lastly H2SO4. Yeah, let's move on. Are you true? Are you done? You don't have what to. If you have questions, you can bring them out. So you can deal with them. Which one is giving you problem? Something I can just look at and give answer. The answer is +3. Some of you like that because I wrote this one outside, you would have been multiplying with -1. I know what you can do. I know. Especially the mathematicians among you. So, what's the answer for the first one? For the vanadium. So the name will be what? Vanadium 5 oxide. What's the answer for the second one? +6. Oh yeah, let me do this one for the sake of those that couldn't do it. So for V205, we are looking for that of vanadium. There are 2 of it, so we will write 2. Then we are looking for, we don't know what the oxidation state is, so we call it X. Sum it all together, then you put what? Plus Abi, then you put 5, right? For oxygen, then that will be -2 equals what? 0, right? So from there now, this will be 2x minus 10 equals 0, right? 2x is equal to 10, x is equal to +5. 10 divided by 2. Is that okay? So we call it vanadium 5 oxide. Check it. Now for the second one. What is that one? So for the second one, that's K2Cr2O7. K2Cr2O7. So we are looking for chromium, Abi. We have 2 potassium, so you write 2. Then put the +1 in brackets, Abi, plus, you don't know chromium, so that's 2 into x, plus 7 into -2 equals what? 0. Abi? So at the end of the day, can you solve for that now? So if you solve for x now, you are going to have 2 plus 2x minus 14, right? So at the end of the day, you're going to have 2 plus 2x minus 14 equals 0. So 2x is equal to 14 minus 2. 2x is equal to 12. X is equal to +6. So this is potassium heptaoxodichromate 2. I mean 6. Abi? That's what you have. Then for the third one, don't worry, I can't blame you. You have not done acid, base and salts. You have done transition elements now. So for what you have here, someone is saying, how do you write ionic equation for reactions? When you write the reaction, okay, it's 130 already. So for this, ammonia is neutral, is 0. So you don't even need to disturb yourself. Ammonia is 0. So you will now call this one X. I know some of you have been saying 4 times minus 3, 4 times 3, that's 12 times plus 1, and so that's going to be X. X plus the whole of ammonia is taken as 0, neutral. So that will be 4 into 0 plus minus 2, Abi, because you know this one is 2 into minus 1. So there are 2 into minus 1 plus the last chlorine minus 1. Everything will be equal to 0. So that will be X minus 2 minus 1 equals 0. So X is going to be plus 1 plus 2, and that's going to be plus 3. So this is dichlorohexamine ferrate 3-chloride. So we'll talk about that later. So for ionic equation, anytime it's solid, don't split it. When it's aqueous, you can split it to ions. So they are separate ions. You can split aqueous solution. For an aqueous solution, let's say I have NaOH plus H2SO4 to give me NaCl plus H2O. Na2SO4 Abi plus H2O. You know, this will be liquid. This will be aqueous. This will be aqueous. This will be aqueous. So when you are writing ionic equation, all the ones that are aqueous, you split them. So this one is going to be Na plus so this is going to be Na plus OH minus. You are able to split because it's an aqueous plus H plus like plus SO4 2 minus to give Na plus SO4 2 minus plus you give that one. For liquid and solid, you don't split them. So which means that this is aqueous, 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 aqueous. So you now look at it, which one is repeating? Sodium and sodium. Hydroxy, no. H plus, no. SO4, SO4. So what really happened here is that H plus reacted with OH minus to give H2O. So this is neutralization reaction, not the full story. So this is what we call an ionic equation. So the aqueous, you split them. The ones we cancelled out there, they are called spectator ions. No. So for solid, for gas, you don't split them for liquid. So we can talk about that again when we see tomorrow. So, Stephanie Lebleso, Lemasi, Leshilataro. What did you say? Which compound? This one. Right? This is dichlorotetramine ferrate 3-chloride. This is dichloro. There's a way you name it. We'll talk about that later. Dichlorotetraamine-ferrate 3 chloride. Dichlorotetra 4 tetraamine. Amine is called amine. Dichlorotetraamine-ferrate 3 chloride. The 3 is the oxidation state that we got. Ferrate 3 chloride. Is that taken? So you can give one of yourselves that name. So anytime you are going, just like tetra